Hello, my name is Liat Margolis, and my talk today is titled Everything is Connected, Rethinking Green Roof Guidelines for Maximum Co-Benefits and Minimal Environmental Impact. In 2009, the City of Toronto launched its Green Roof Bylaw, which requires that all new construction above 2,000 square meters install an extensive green roof. And this was quite ahead of its time. City of Toronto was the first of North American cities to legislate such a bylaw. And this was based on a Ryerson University report, which demonstrated that an average of 50% water retention and substantial surface cooling would be achieved relative to conventional rooftops. And that was a very monumental achievement for the City of Toronto. Fast forward 10 years, and the City of Toronto boasts over 700 green roofs and well over 5 million square feet of green roof installed. Around the same time, my colleagues and I at the University of Toronto, collaboration between the Architecture and Landscape faculty, engineering, biology, and most recently forestry, we took on this project to set up an experimental lab to look at the evidence-based research and common industry practices relative to the construction guidelines that was published alongside the Green Roof Bylaw, and from what we learned that are the common industry practices in and around Toronto. And the main question was that we asked is how green are green roofs? How well are we doing in terms of the environmental performance that we ambition? And just for context, the Toronto Green Roof Construction Standard and the Toronto Green Roof Bylaw is part of a much larger suite of policies, strategies, and guidelines in the Toronto region, which aim for an approach around cross-cutting environmental ambitions, an understanding that ecosystem services, co-benefits of living infrastructure exist at multiple dimensions of environmental management, at multiple scales, from urban forestry down to architectural scales and material scales, street level, and so on. And that the ambitions that we have around stormwater management relative to reduction of flooding, the increase of biodiversity and species habitat, the reduction of pollution and increase or maintaining of air quality, reduction of urban heat is all interconnected, and that we have to really think about it as multiple systems that are occurring simultaneously and also in concert with one another, and thinking about the impacts regionally and locally. And so when we're talking about the Green Roof Construction Standard relative to the Green Roof Innovation Testing Laboratory, which is the lab that I co-founded with colleagues at the University of Toronto, we're looking at 4 primary design factors that are part of the construction standard. The first is the growing media composition. And this is a recommendation to follow a German standard or a German guideline. And the recommendation is that the composition is largely mineral content with very low organic content. It's designed to be fast draining and largely mineral aggregate. The second recommendation has to do with growing media depth, and this is the reference of the so-called extensive green roof. Extensive green roofs are between 100 millimeters and 150 millimeters. And the minimum requirement for the City of Toronto is 100 millimeters. As far as irrigation, water conservation is recommended but also irrigation to sustain green roof survival. And then in terms of planting, there is a recommendation to plant sedum mats or succulent planting. The general rule in terms of coverage is that at 2,000 square meters, there's an expectation for 20% coverage, and then it goes up from there. So this is an image of our testing lab. On one of our testing labs now, we have two, looking at 33 test beds that examine extensive green roofs between 10 and 15 centimeters. And we're looking at stormwater management. In other words, what is the capacity of the green roof to hold on to water and reduce discharge, or reduce runoff, and alleviate the pressure on urban water systems and flooding. What's the thermoregulatory capacity of plants and green roofs via evapotranspiration, and also surface cooling relative to blacktop or conventional rooftops? What is the survival rate and plant cover percentage, and as well as biodiversity? And what's the relationship of green roofs to pollinators? And as you saw before, there is an ambition for the City of Toronto to become bee city or increase pollinator habitats. And the main question relative to the design parameters is, what are the most significant design parameters for any one of these performance criteria? Now we're a little bit further on the design factors. The primary medium or growth media that is used in Southern Ontario, and this could be said for many other regions in North America, follows the FLL guideline, which, as you can see on the bottom left, has the relatively large aggregate mineral-based media. On the right is an alternative biologically derived wood compost-based media with high organic content. What you could see from this graph, and this is just a lab test, looking at the water storage capacity of the FLL in the lighter blue and the biologically derived compost-based in the darker blue, already showing from the get-go a much larger, higher water retention capacity. The other design factor we're looking at is on the right, the common sedum mat that's installed, and I would say that that is probably 70 to 90% what the industry is still installing. And on the left, a combination of herbaceous plants, primarily native plants, and there, you could see a kind of a heterogeneous structure, a much larger biodiversity in terms of, on the right is a singular, or what's called a monoculture, and on the left a more heterogeneous biodiverse mix of plants. You can also see the flowering nature of it and the kind of the seasonal variation in planting over the growing season. The sedum comes in pre-grown mats in nurseries that are rolled and then installed pre-vegetated. One of the reasons that industry and builders like it is that you have a kind of an instant landscape at ribbon cutting. One thing that's important to mention is that sedum and sedum cultivars are non-native to Southern Ontario. There are a few cultivars that are native to BC, but those even in the mix are not thriving. And so this is something that to keep in mind for later in the talk. Well, I'll talk about the importance of native versus non-native and relationship to pollinators. This is just a close-up of the different herbaceous plants that we experimented with, and these are all common, resilient, ruderal species. You can find them on the side of the road in any sort of Southern Ontario landscape: the echinacea, the yarrow, the primrose, aster, and so on that are very hardy and do quite well. The third is looking at, third variable is looking at irrigation treatments. And the two common practices relative to irrigation are automated daily irrigation and no irrigation. And with respect to no irrigation, one thing that's really important to note is that LEED and green building points or standards attribute points to non-irrigated landscapes, or at least non-irrigated with potable water. And so that's one practice. The other is that green roofs are marketed largely as no maintenance landscapes, which we'll get to in a bit in a discussion. And of course, there's a cost associated. So you will find many of the green roofs that are installed around Toronto with no irrigation. The third is something that we took on with the question of what if we installed a soil moisture sensor irrigation, insofar that when the soil is dry, the irrigation system would not turn on, and like conversely, when the soil is dry, it would trigger the irrigation system, so on-demand irrigation. And what we found was that with the on-demand irrigation, we could achieve up to 50% water conservation, so that's quite significant. So in summary, we've got a multifactorial experimental design, and this is really important to think about because we're talking about ecosystem services. We're looking at multiple performance that we're trying to achieve with a living system. And we're also looking at the fact that there are multiple design variables that are contributing in sometimes different and opposite ways to one another towards an environmental performance. So here we're looking at, on the right column, the different alternatives that we're looking at. And the fourth element that I didn't address yet is the width, the depth. Where we're looking at 10 centimeters or 100 millimeters, which is the minimum requirement for the City of Toronto. And then we're also looking at 15 centimeters. The question is, if we increase the depth, do we see a difference in the environmental performance? And here, what's really important in terms of depth is that obviously more soil is more cost. More soil or more grown media is more environmental impact. More depth and weight on the roof requires more load-bearing capacity. So again, when you're looking at the entire life cycle cost, the question is, if we increase the media depth, does it actually weigh out the environmental impact for the environmental benefits that we're getting? All of our lab is instrumented with sensor instrumentation. We're looking at sensors that are integrated into the bed, surface temperature, air temperature, soil moisture sensors, rain gauge, which is at the bottom left of the rendering there, looking at water discharge from the bed. And each bed is then measured against a weather station that's recording the climate data on our roof. So what have we found? As I said before, prevalent industry practices look at the mineral aggregate, the sedum, and either daily or no irrigation at or less than 10 centimeters. And I'll get to that during our discussion when we're talking about the construction standards or supplementary guidelines from the City of Toronto. And what we have found, in contrast, is that the organic medium was far superior relative to stormwater management or retention, water retention capacity, also for thermal cooling, and for the support of a much larger range of plants, not only sedum, but also the herbaceous vascular plants. And of course, the on-demand irrigation proves to be a much better solution than the daily irrigation for water conservation, and a great compromise to sustain a broader biodiverse plant community and increase thermal cooling and reach that kind of balance between water conservation and environmental performance. A little bit further in detail. So we know that on average, green roofs, from other studies and reports, that green roofs on average hold on to 50% of the water. And what you're looking at here is runoff coefficient. So percent retention is the reverse. So 0.4 would be 60%. What we found is actually a better news. So 60% on average across all the different configurations. So that's really good news in terms of thinking about the viability and the benefits of green roofs. But you can see how irrigation, which is the first column in the regression analysis here, is looking at when you do use daily irrigation, you drop to 50% from 60%. No irrigation will give 70% of water retention, and the same with the soil moisture sensor on-demand irrigation. And this is the second most significant factor is the medium type. So the growth media, when we use the mineral aggregate, again drops down to 60%, and with the biological media, we can maintain up to 70% of water retention, which is quite significant, especially if 50% is now the kind of the going standard for calculation for engineering. So in summary, organic media plays a significant role in increasing stormwater retention in modules that do not receive irrigation. Depth or choice of vegetation does not significantly influence the hydrological performance. And that is I think, a really important message, and I'll discuss that a bit later when we talk about the FLL standards that are dictating a lot of the industry practice in Southern Ontario and in Toronto. What's interesting also about the organic media is that the volumetric water content is far superior between the biological and the mineral. And you can see the biological in the dark gray holds on to the water content at a much greater rate. And what's important to note here is that the organic media water retention capacity increases when pre-wet. And that's really important when we're talking about back-to-back storm events, when the soil is already wet. The FLL will drain immediately. In contrast, the organic media will just continue to hold on to more water. It's also pre-wet condition could be with prior irrigation the day before, and the soil is still wet. So another added bonus for this. And what's also important about this organic media is that the bulk density and the overall weight is much lighter than the FLL. So thinking about the life cycle costs and load bearing capacity, as well as retrofit of buildings that have a limitation in terms of the load bearing capacity, this would be a much better solution for the compared to the FLL. This was another study that we ran, and what we found was that obviously, the bottom line is plants, growth, media, and water are an interrelated relation. You can't think about plants and water independently, which is one of the biggest challenges and sort of givings in green roof practice. What you can see here from this study is that there is a sharp decline of cover and survivability with the what we're calling our meadow or our herbaceous plants when there's no irrigation. So irrigation is absolutely essential for non-sedum planting. The sedum maintains upwards of 90% of cover despite lack of irrigation and irregardless of the growth media. However, what you can see here from some of the more patchy sedum beds, for instance, the one on the further right, is that when the sedum over time grows on top of FLL media with no irrigation, it will begin to become patchy and lose cover. And we found that over time. And cover is really important. The result of lack of cover is basically scour, wind erosion. You can see how the growth media in the beds over time is lost due to the lack of roots and plants. And that correlates with thermal cooling. And you can see some of the beds that are losing cover, particularly the one, for instance, on the bottom second to the right. And that is an FLL, no irrigation with our herbaceous or meadow planting. And within 1 year, and that was a year of prolonged drought, and an elevated temperature, and we pretty much lost that bed, and the plants never revived. That bed never recovered. And you can see that kind of patchiness. So all the ones that are, as you can see, that are thriving are and are very dense. And also, if you compare sedum beds to other sedum beds, where you can see that the biomass is really thick, that there's a kind of not only 100% cover, but that there's also a vertical mass of the plants relative to the ones that are becoming more and more patchy. That is because they are either sitting on organic medium and or organic that is also irrigated. But certainly the combination of sedum on top of organic is far superior, and especially when you're dealing with the herbaceous plants, the organic media in irrigation is essential. And what happens in terms of thermal cooling is that on average, we're looking at surface cooling. So above 6 inches above the beds, the thermal cooling is relatively negligent. It was comparable to what we were recording with the weather station, and this is because of wind. But at the surface, we're seeing a significant cooling of temperature. So, 2 degree temperature difference with the ambient temperature, but you can be, in general, with a green roof with a healthy cover, close to 20 degrees difference with a blacktop roof that's absorbing solar heat or solar radiation. Interestingly, the bed that I mentioned that perished in year 1, that's at the bottom right there, was 11 degrees hotter than the ambient temperature. So we can very much with certainty say that if we are installing green roofs that are going to fail, we can do more damage in a sense. I mean, we're just as bad as the conventional blacktop roofs, but now we've also have all the embedded energy costs that have gone into the construction of the green roofs on top of that. So the environmental impact is really negative. And what's important to note is, besides the cover versus structure, so the cover is what's essential for thermal cooling, is this idea that, again, there is no one variable. You can't really look at one variable in isolation, that they all have to always be considered in tandem. Plant media and water are essential to the kind of plant cover, as well as the thermal cooling that's generated with evaporation so due to irrigation. Now, I want to talk about where we are in terms of industry practices relative to FLL guidelines, which are the primary guidelines that the City of Toronto references, and the City of Toronto is not the only one. There are many cities across North America that are looking at this FLL guideline, which is generated in Germany. Germany obviously is a leader, has been a leader in green roof for a long time. But I want to point out just some inconsistencies and food for thought in terms of how we move forward with guidelines and thinking about green roofs, and particularly in this region. First, I think one really important a misconception or this kind of inconsistency to point out is the difference between the definition of intensive green roofs and extensive green roofs. In Southern Ontario, the idea is that extensive is based on depth. It is 10 to 15 centimeter growth media and construction. However, and intensive is above that. And FLL guidelines really talk about this idea of maintenance. So there, if you look at the text here, they're talking about a type of green roof that can be sustained through intensive care, especially regular water and nutrient supply. And so they're relating the kind of limitations or restrictions around planting perennials, grasses, flowers, summer flowers, and so on, to the idea that that it's about maintenance, that it's about intensive care, that it's about a kind of a limitation on that. In contrast, the idea about the extensive green roof is that it's self-sustaining, it's low maintenance or no maintenance. And so the message, I think, that have, and you could see here the vegetation are mosses, succulents, and so there is a kind of idea that green roofs are, that irrigation is essentially an intensive practice. And so this is something I want to bring out in terms of the notion and the question that should guidelines around green roofs be universal given different climate and eco-regional variations. So we have different rainfall between Eastern Canada, Central Canada, and Western Canada. Certainly across North America. Would you compare Toronto to Texas or California or Colorado or Florida for that matter? How can we take guidelines that are generated and are thinking so restrictively around this notion of disregarding climate specificity with regards to rainfall, the media that's and growth media that's available regionally, and the kind of flora that's available regionally. The other thing that I want to point out is the linking of growth media depth to water retention. And these are references in the FLL around this idea that the only way to increase the water retention capacity is to increase depth. And what I've shown you before is that with actually rethinking the composition and structure of the growth media, we can increase water retention capacity and nutrient availability to support a much wider variety of vascular plants without increasing the depth. And so here's another misconception, I think, about linking only growing media depth to plant selection. In other words, if you are thinking about a kind of a thinner construction, you're limited to sedum, and if you're thinking about the more herbaceous greening, you have to increase your depth. And I would argue that it's really about the kind of material composition that we should be looking at, and the kind of also the notion of irrigation in concert. Now, organics are vilified quite a bit. FLL is restrictive around organic input, particularly with this idea that in the first year of construction, organics would leach. There's also an ongoing myth going around compaction and loss of organics. And what we found was that in a survey that we did of 20 roofs, that some of which are 20 years old in Toronto, that there was no compaction and loss of organics, and this is due to a natural process of pedogenesis, which is essentially the creation of soil due to the organic matter that is then added to the soil via the plants that are there. So if you have the right combination and you've thought about what am I growing and what should it be growing in, and does it need water irrigation to maintain cover and full health, you've got an ongoing and healthy process of pedogenesis and soil creation and no loss of organics. The other myth is that about this nutrient loading, the nitrogen and phosphorus, which would create eutrophication and algal blooms in our water systems. And we did a quick calculation. If all Toronto's rooftops were covered with organic green roofs, the output of nitrogen and phosphorus to Lake Ontario would be an infinitesimal fraction of the output that's coming out of the wastewater treatment plants to Ontario. Likewise, we don't vilify fertilizers that are going into our park systems or gardens or any other landscape in the urban environment. So why are we so strict with the presence of green roof, of organics in green roofs? And I would argue that part of the logic is that green roofs fall between green infrastructure or living infrastructure, which are these vegetative-based systems, and low impact development, which also include cisterns and porous pavement that obviously don't output any nutrients into our water systems. And that's where the kind of the industry myth around these organics. And the other thing that I think is worth mentioning is the fact that with the organics, a large portion of them are recycled content. They're coming from waste streams from wood mills, for instance, pine bark, and so on. And as I mentioned before, they also have the low bulk density, and so much more advantageous in terms of thinking about a full life cycle cost. And then to seed them or not to seed them, obviously, is the question. That this is the primary go-to for a lot of green roof construction, and this kind of notion and certain studies that have come out that they're trying to prove that herbaceous plants are not sustainable and cannot be grown on a shallow, extensive green roof. And of course, those studies looked at a growth media that was inappropriate to herbaceous plants. So, you know, with every landscape, you're always thinking, what am I growing and what is the appropriate soil or growth media to support that plant? And why is it important? So we ran a study which was peer review published, that looked at the relationship with pollinators and pollen loads relative to the sedum plantings or sedum beds in our roof and the herbaceous plants. And what we found was that the native wild solitary bees were attracted primarily to the herbaceous plants. They also visited the sedum plants, but they went to the herbaceous plants as well. And the non-native species, these are the domesticated honeybee, and these are European species, gravitated primarily to the sedum. And it's important to mention that, make the distinction between the domesticated bees and the fact that Southern Ontario has 365 known native solitary bee species, and those are the ones that are in in danger. Those are the ones that are in decline, and that are very much in concert with and have symbiotic relationships with native plants. And so when you have a decline in native plants in an urban environment, you'll see a corollary decline in wild bee species. So the question here is, if we are planting, and if you recall, I mentioned 5 million square feet of green roofs across Toronto over the last 10 years, if 90 or 70, even 70% of them are sedum mats, are we creating these kind of priority landscapes that support non-native bees and outcompete the native solitary wild bees? And that's the question. More on pollinators, and this was a general study that we did looking at building elevation and green roofs. And does building elevation matter, given that a lot of the construction here in Toronto is 20 stories all the way up to 100 stories? And do pollinators actually visit rooftops that are at such elevation? And what we found was that above the 8th story, there is a sharp decline in bee visitation. And so the conclusion there is designing for biodiversity at the 60th floor is not really purposeful. And we should think about the city as a 3-dimensional structure, looking at, for instance, the tower over the podium, where the podium is actually designed as a green roof for biodiversity for pollinator species with a much more biodiverse planting. And the green roofs that's installed at the 60th floor is perhaps a sedum mat just to maintain cover, or maybe we just put a white roof, because at that point the green roof is not really contributing much, and all we're looking for is just solar reflectance. And so the conclusion that I would put forth is that not all green roofs are created equal, and nor should they be. We should be looking at our city environment as a 3-dimensional environment. We should be looking at context, and we should be asking ourselves, what are the environmental performance aims that each site requires? Now back to the Toronto guideline, and here I want to point out some of the kind of confusion or inconsistencies and where I think we could be doing better. So in terms of growth media and best practices, it's referring to the FLL standards, and I've pointed out to some of the kind of the misgivings around depth, the restrictions of organic content, the very specific specifications around granular distribution, porosity, dimension, without actually asking the question, what are we planting? What are we growing? What should the soil be? The second thing is that the applicant shall provide a report confirming that the engineered system as designed provides plant survivability if it's not 100 millimeters. And so there's actually, the reality is that while there's a requirement for a minimum 100 millimeters of construction, many green roofs are actually installed at a much lower depth, and that does matter. Another is to look at best practices relative to plant selection, and there's a recommendation, as you can see here, with succulents. Succulents are more selected species because of their capacity for storing water in the leaves of roots and because of their low substrate depth. Well, that's okay, but if there is a objective to support native plants in Southern Ontario, and we have strategies for biodiversity and native plants and native pollinators, then why are we specifying and advocating for sedum? And then drought resistance to minimize the need for irrigation. Again, there's a kind of conundrum there and a inconsistency between what are we trying to do in terms of the plants and why are we looking at drought resistant plants, which are obviously the succulent ones. And then a recommendation for non-monoculture. We'll see them are a monoculture. So a whole bunch of inconsistencies in just one section. What's good here is I think that we should maintain no less than 80% of the vegetative cover of the roof. And that is really important, and I think that that needs to stay. But within 3 years, so who's monitoring that? Does the city monitor that? Is there any sort of inspection that occurs? Is there a post-construction evaluation that is required to be submitted, and so on? And that's a gap. And then I think overall, definitely, for a successful roof, the design of selection of growing media, irrigation system, and planting must be carried out as a system. Absolutely. So as far as irrigation, again, adequate measure for irrigation, but the previous page just said drought resistant. So where's the direction here relative to water, relative to the kind of plant selection? And what about the kind of the objectives and the missing objectives for water retention? Where are the benchmarks around water retention that are cross-cutting or cross-referencing to the wet weather flow regulations or ambitions that we have for any site? And why isn't the growth media actually related to the kind of benchmarks around water retention capacity? And then again, with regards to maintenance, so there was a request for maintenance, but no real way to actually enforce and monitor the performance. So this is what's happening in Toronto. We're now doing a large survey of all the green roofs installed since 2009, and this will take some time, but I hope to report that back to you in a couple of years. But this is what's happening in Toronto. We've got 2012 sites within 5 years, 10 new green roofs, some of which, as you can see, and obviously this is a winter shot, but still you can see some of the patchiness that begins to occur with some of the green roofs, where you can see some of the white emerging across the what's shown as brown, but it's not brown because it's not living. It's just because it's winter. But still, the kind of patchiness is very apparent. And from our quick calculations, we're looking at least 30, maybe even 50% of that kind of condition of patchiness and degradation that happens over several years. And I want to remind you that we're talking about 5 million square feet of green roofs and rising at the rate of, looking at right now, roughly 1.6 million cubic meters of growth media that was blended, manufactured, mined, transported, and this is the equivalent of the volume of what would fit at the Rogers Center. So we're talking about a huge environmental impact, and the question is, how do we do better? How do we make sure that this is not just lip service, and that the environmental performance is really up to par with the kind of environmental impact, as we heard from Nicole North's and Daniela's presentations around the impact of mining, aggregate, moving soil, and the kind of the larger regional impacts on our environment. And this is also really important in terms of climate change, right? We are seeing these large storm events more and more. And so the idea around optimizing the performance of our green infrastructure is paramount. And of course, we have to remember the co-benefits, the fact that ecosystem services are multiple, the fact that with green infrastructure, we're always aiming to not just do one performance at a time, but multiple objectives. So we're not just retaining water and therefore optimizing just for that, we're also thinking about the biota that we're providing. So in conclusion, How do we reach maximum ecosystem benefits? How do we minimize environmental impact? I think that we should be asking ourselves the following questions when we enter a project. First of all, what are the environmental performance objectives for the site and why? Are they appropriate to the site? Are they appropriate to the building elevation? What design factors are most significant to achieve the performance or performances? And how do we maximize the co-benefits and minimize the impact, the environmental impact of the materials that are going into our green roofs? And likewise, sustain them over the long term. If the green roof fails after a few years, what have we done? The next step is to really think critically as designers, as installers, rather than to just follow guidelines without actually thinking about whether they're really pertinent. What are we planting? Where and why? Number one question. How are we achieving cover? Are we aiming for biodiversity? Are we supporting habitat? Once we answer that question, then the next question that follows is what should the structure and nutrient availability be for the soil or growth media composition? And how do we think about what I say, how low can we go? How do we achieve the least amount of depth for the most amount of performance relative to the composition and structure of the growth media? There's no free lunch. Depth equals weight and also equals environmental cost relative to the benefits. So we really have to think about depth critically. Cyclical economy. I think we should always be looking at recycled, renewable, and local. The FLL is mined and quarried, not around Toronto. It usually comes from upstate New York, Quebec, has a huge environmental cost for aggregate and mining. And so can we think about our waste streams and looking at renewable and sustainable local materials for our growth media? And then optimizing green roof. Let's look at green roof solar. We have studies that show a lower life cycle cost when combining green roof and solar, and also the possibility of integrated water management, reusing cistern collected water for irrigation, particularly where all new construction falls under the wet weather flow, having to hold on to 90% of site runoff. And so many of the new construction that are built in Toronto has an underground cistern and has to be reused in irrigation. Why don't we think about it as a full cycle, also then supporting and solving the kind of conundrum around irrigation or no irrigation, and looking at it as a full site strategy. And I'll just leave you with a couple of images looking at some of our other studies, which I'll be happy to share at another time about the benefits of green roof integrated solar and a new projects that we recently studied looking at the reuse of cistern collected water from the entire site at One Spadina Crescent, where our Faculty of Architecture, Landscape and Design is located, looking at that for reuse and irrigation on our green roof. And this is it for my talk. I thank you very much.